Made in Space, Inc. is an America-based company, specializing in the engineering and manufacturing of three-dimensional printers for use in microgravity. Headquartered in Mountain View, California on Moffett Field, Made in Space's 3D printer, Zero-G printer was the first manufacturing device in space. History. Made in Space was founded in August 2010, by Aaron Kemmer, Jason Dunn, Mike Chen, and Michael Snyder, during that year's Singularity University Graduate Studies program. Their primary mission is to enable humanity to become a multi-planetary species. In the spring of 2011, Made in Space created their 3D printing lab, at the NASA Ames Research Center, on Moffett Field, Mountain View, California. That summer, they were awarded suborbital flight, through NASA's Flight Opportunities Program. From July through September 2011, the Made in Space team performed over 400 microgravity test parabolas, on NASA's reduced gravity aircraft, the Vomit Comet, proving their 3D printing in microgravity. With this proven concept, Made in Space was awarded a Phase 1 Small Business Innovation Research grant, with NASA, for the design of a 3D printer to be tested on the International Space Station (ISS). In January 2013, Made in Space was awarded Phase 2 of the SBIR, by NASA, to build and flight qualify an additive manufacturing facility, with their 3D printer, for the International Space Station (ISS). Phase 3 was awarded in February 2013, as a sole source contract to fly their 3D printer to the ISS. In May, NASA and Made in Space announced the 3D printing in Zero-G experiment, which would put their 3D printer on the ISS. In May 2014, NASA awarded Made in Space a Phase 1 SBIR contract for the development of a recycler unit, to use with the 3D printer on ISS, and for their Microwell project. Shortly after, Made in Space was awarded an ISS Space Flight Awareness Award. This award honors teams that have significantly improved the efficiency, cost or capabilities of space flight. In June 2014, Made in Space, Inc. showcased their in-space manufacturing capabilities at the White House Maker Faire, on Sunday, September 21, 2014 at 1:52 a.m. Eastern Daylight Saving Time (0552 GMT). Made in Space's Zero-G printer was launched from Cape Canaveral, Florida to ISS, on board SpaceX CRS-4. On November 17, astronaut Barry Butch Wilmore unpacked the 3D printer from its launch packaging. On November 24, at approximately 1:28 p.m. Pacific Standard Time, Made in Space successfully printed the first part ever manufactured in space. On December 11, 2014, at Autodesk University 2014, Chief Strategy Officer and co-founder Mike Chen revealed Made in Space's first functional application, a buckle developed by NASA astronaut Yvonne Kagel. This buckle is part of exercise equipment to assist with the reduction of muscle loss in zero-gravity environments. On December 12, 2014, the Cooper Hewitt Smithsonian Design Museum reopened after 3 years of renovation, as the new Cooper Hewitt. Dedicated to contemporary and historic design, Made in Space's 3D printer was one of their grand reopening exhibits, in their "Tools, Extending Our Reach" Exhibit area. The zero-G printer was featured along with replicas of 13 of the first 21 objects printed in space and a replica of the plate affixed to the printer, which was created by John Lomborg, the artist who designed Voyager's Golden Record. On December 17, 2014, the first uplink tool, a ratchet, was manufactured on ISS. All of the other items previously manufactured were printed before launch, and the files were available via an SD card launched with the printer. The ratchet files were uplinked from the Made in Space office to the ISS space station. The ratchet took 4 hours to print. Topic: 3D printing in zero-G technology demonstration. Announced in May 2013, NASA and Made in Space partnered to send the first 3D printer to space, known as the 3D Printing in Zero-G Technology Demonstration, also known as 3D Printing in Zero-G Experiment or 3D Printing in Zero-G. The scientific objective of this experiment is to prove a 3D printer could be developed for use in zero gravity. This experiment is the first step towards establishing an on-demand machine shop in space, a critical enabling component for deep space crewed missions and in-space manufacturing. Integrated into a microgravity science glovebox (MSG), 3D printing in zero-G is a proof-of-concept experiment. It includes printing multiple copies of planned items to test for several variables, including dimensions, layer adhesion, tensile strength, flexibility and compressional strength. Known as coupons, these items will be tested by the American Society for Testing and Materials (ASTM) and compared to duplicate items printed on Earth. The comparisons of these space and terrestrial manufactured coupons will be used to further refine 3D printing in space. The John Lomborg Golden Plate. Inspired by John Lomborg's work on the Voyager Golden Record, Lomborg worked with Made in Space to create the Golden Plate to help commemorate the first manufacturing of something in space. It is attached internally, so it is visible through the front viewing window. The Golden Plate features imagery that symbolizes both the 3D printing in zero-G project, and the individuals who have been instrumental in bringing the project to fruition. These features include 27 stars, which represent 16 key contributors from the Marshall Space Flight Center, 10 key Made in Space, Inc. employees and John Lomborg, a comet to symbolize all of the other people who supported Made in Space, and Star Trek character Jean-Luc Picard's catchphrase, "Make it so," in binary, symbolizing the functionality the 3D printer brings to the ISS. Additive manufacturing facility. As of February 2015, the Additive Manufacturing Facility (AMF) addition to the ISS was scheduled for deployment in 2015. This NanoRacks facility, featuring Made in Space's zero-G printer, was intended to be used to manufacture parts both for NASA and other space agencies, as needed on ISS. In addition, additive space manufacturing was intended to also be commercially, with the AMF, for anyone around the world. Recycling of 3D printer plastic. In 2014, NASA selected Made in Space as one of several companies to develop a recycler for 3D printed material on the ISS. In the follow-up solicitation, Made in Space failed to be selected for the Phase 2 SBIR. Large structure in space manufacturing. Made in Space is partnering with Northrop Grumman and Oceaneering to build and demonstrate Archinaut, a versatile in-space robotic precision manufacturing and assembly system. Archinaut enables in-space production and assembly of the backbone structures for large telescopes, repair, augmentation, or repurposing of existing spacecraft, and unmanned assembly of new space stations. MISS is currently in ground testing of program technologies and expects a flight demonstration in 2019. The company has released video demonstrations of Archinaut's robotic assembly and robotics development lab, as well as animations showing Archinaut's in-space assembly and manufacture capabilities, ULISSES and DIALO. Space for Earth capabilities. Made in Space began launching fiber optics research and product development flights to the International Space Station in 2018. The multi-flight experimental payloads are producing test quantities of ZBLAN optical fiber. Based on the results from initial experiments and market demand, Made in Space plans to develop and operate larger-scale microgravity production facilities for ZBLAN and other microgravity-enabled materials. For its fiber optics development, MISS is teamed with Thorlabs, a world leader in terrestrial optical fiber solutions. After manufacture on the ISS or future commercial platforms, fiber will be brought back to Earth for commercial customers. The advantage of fiber optics produced in microgravity are much lower signal loss capabilities, which benefit long-haul communications, medical research, supercomputing, and many other industries and applications. Other product research and development activities. In 2018, MISS was awarded Small Business Innovation Research Award extensions of 24 months for its Vulcan and Industrial Crystallization Facility (ICF). The Vulcan Advanced Hybrid Manufacturing System is an additive and subtractive manufacturing technology being developed for in-space applications. Vulcan enables fabrication of precisely machined metal parts at the point of use, such as on the International Space Station or future crewed space platforms. The ICF International Space Station-based device will manufacture space-enabled, multi-use optical crystals in microgravity. Optical crystals are used by such industries as computers and data processing systems. See also: Tethers Unlimited, Inc.